I've spent an insane amount of time and only slightly less money to make plugs and molds like this and like this so that they could produce literally quantity one carbon fiber part out of each one. And more than 90% of all that effort goes into the mold. It doesn't even go into the part. And that's the reason for today's video. I want to find the cheapest, easiest, fastest way to make a mold that'll still produce a good part. And for that, we're going to be using 3D printing. I have some successes, as shown here, and some failures. So let's get into it. I'm using a bunch of old scrap carbon to make these parts, so really it's no loss but time if this thing all goes south. The first thing I'm going to do is lay down some blue painter's tape on the inside of this mold that I can then take out and make my template for both the peel ply and the carbon layers. With the template finished, it's pretty quick work to run around it with this roller knife and get the carbon cut out. The next thing on the agenda is to get the vacuum bag ready. Now, unlike resin infusions where you put the vacuum bag directly on the mold surface, we're going to be creating an envelope bag, which is exactly what it sounds like. You're going to put the entire mold and part all the way into the bag and vacuum bag the entire thing. Now, one important thing to note here is you want your envelope bag to be at least 2 to 3 times bigger than your mold. Too much vacuum bag is always better than too little. The reason you're doing that now is so that you have one less thing to screw around with while the resin is in your part curing and you need to get it under vacuum. All right, I think I've done all the prep work for this layup. So let's touch on all the materials quickly and the game plan. PLA mold, that's going to be released with just a layer of peel ply. That peel ply is from fiberglass. We're going to make the layup out of 6K carbon. You can see the templates cut there. I was going to start with 6 layers and then do 12 on the face for bulk. I've reduced that down to 4 and 4. I just think 6 was overkill. So that's 6K carbon, 2x2 twill. For the epoxy resin that we're going to be using, this is Fiberglass New 2000 series or 2001 series laminating epoxy resin. It lays up in room temperature and cures in room temperature, no need for post-cure, and it's got really good properties, so that stuff is going to be pretty sweet. For the vacuum bag, this standard vacuum bag, we're envelope bagging it. I did make this little pigtail. In college, I learned about this. You can basically make this pigtail with a little bit of breather in there, and you can use those between envelope bags, and it just saves you some hassle later. So that's prepped and ready to go. We are using just standard breather. That breather is put in there for 2 things. One, it's to distribute the vacuum, so it gives the air a path to travel when you start pulling it down, and it also soaks up extra resin. We are going to lay this in pretty resin rich. Spray adhesive, that's just to keep it in place into the mold. On top of that, I'll start just wetting out and laying down each layer individually. So we'll do one on the base, that's the bigger t-shirt size template, and then between each one of those, we'll put the rectangular template on the face to give that bulk where I want it on that face. So we'll build it all the way up. I have some extra peel ply over here that I'll use to cover the whole mold and any exposed surface when we're done with the layup. And then I have extra breather that I can put over the whole part before I place it into the bag. All right, there it is. It's all vacuum bagged. I got it down to about 25 inches of mercury, which I think is plenty. I made sure to come in here. Oh, there's kicking back on. I came in here and pushed all the edges in. That's where I really wanted to get into those corners and make sure that it was nice and close so I don't get any interference from my bolt holes. It's been a little under 24 hours, but I think it's fully cured. Let's see if we can get this thing out of the bag. Well, that Absolutely did not work at all. Let my failures be your lessons. Couple things I think that caused the issue. One, I should have put a bigger draft angle on the outer edges. There's no reason they need to be vertical, and I think that's caused a pretty big issue in trying to get these things out. Um, Not that that was the only problem. The peel ply worked kind of okay-ish. Um, I think I should have just played it safe and put in a whole bunch of wax in the bottom of this thing just to give it a barrier, so it would hopefully release a little bit better. But that is what it is. So after a lot of thought and to keep with the theme of the least amount of effort to produce a part with 3D printing, I'm not going to seal the face of this mold. The reason you would want to is because since it does have vacuum accessible to the back of the face, and if that face is porous, that vacuum will suck all of that epoxy resin, or some, through the surface of that mold and out of your composite part. My thought process there is the epoxy resin is thick enough, viscous enough, and the holes in the surface of this are probably so small that the amount of loss will probably be very, very minimal. So I'm going to ignore it. I am, though, from what I learned last time, going to use Partol paste for my mold release. I want it to come out of this a little bit easier, and I'm hoping that that will help me do that. Everything else about this layup will go basically exactly the same, with one more exception. Typically, you would use what's called release film on a hand wet layup like this that would go between your peel ply and your breather. That release film is a film that doesn't stick to the resin, but it has some very small holes in it that limits the flow of the resin from the carbon part into the breather, which, as you remember, that was my main issue. The breather sucked up all that resin. And there is the part. The whole demolding process was relatively uneventful. The part is solid. It is stiff. You can even tell if I hit it against something solid. You can kind of hear it ring, where the old piece is just like a wet noodle. It's just soft. So all in all, everything worked out really well. This thing's really strong. We'll get this trimmed up. I'll throw it in there and we'll see how it actually fits. All right, so how did we do and what did we learn? Well, 3D printing molds is a perfectly good, viable way to make a mold cheap and quick. And you can actually do a whole lot with it right off the printer and very minimal prep work to make your part. We'll start with the foot pedal bracket. I went ahead and I trimmed it up. This thing is built like a brick shithouse. Stronger than hell, probably way overkill, and definitely stronger than the fuselage. It weighs in at about 100 grams, so very, very light and very, very strong. Obviously, it fits the contour in the helicopter perfectly, and it exceeds, honestly, my expectations. The do's and don'ts. One, I screwed up, and I was basically just impatient. I put the part under a space heater to get it to get hot, and in doing so, I warped the mold pretty bad. So this mold is now scrap. The peel ply idea worked out perfect. And if I didn't mention it before, the reason I really wanted to do that is because I'm going to be bonding this into the helicopter, and I wanted that peel ply texture to help me with that bonding surface. And so that was it kind of killed two birds with one stone. It gave me that texture, but also worked as a perfect release agent to get the part out of the mold. So that was really cool. I would absolutely do this again. There's probably like $5 in printing material in this thing, and basically no prep work to get a part out of it. So super, super cool. I'll definitely do that again. As always, go build something cool. Never stop learning, and we'll see you on the next one.